All right, well, let's get this party started. Welcome everyone to the first and what we hope is actually a series of webinars on moisture-related issues. Want to welcome all of you for signing up. A lot of names I recognize. Oop, picking up echo. There we go. All right. So yeah, actually, that brings up a good point. So I'm coming to you from my quarantine home office, otherwise known as my basement. So hopefully there won't be any interruptions, but you never know who can control the dog. So we'll see if they show up. I'm sure all of you have had issues like that as well. So again, I'd like to welcome you all to today's webinar. Many of you are familiar names. I've known you either from countless refrigeration related classes I've done over the last 20 years in this industry, or maybe you saw me at IAR, Rita, ASHRAE, something like that. Maybe I presented at your company. In any case, I have been with Quest for now just shy of 2 years, focused on primarily the industrial market. That could include, well, we'll talk about all the different markets we're gonna address here. So today's seminar, probably you signed up for it because you're planning on going to the Technomercial at IAR. Hey, sorry, it's beyond all of our control that was canceled, but we like to thank you for showing up again anyway. That said, this isn't intended to be a giant Technomercial sales pitch. We just want to first start out by talking about some of the moisture-related problems and how we can address the root cause before we finally get to our new line of desiccants that we're rolling out for the industry. So what industries, what applications are we talking about? What industries are we going after? Who have I heard from? This is just a sample of who I've heard from over the last 2 years. And the cold storage and the whole cold chain industry, a lot of distribution centers, public warehouses, private cold stores attached to production, and of course, all of those facilities with their loading docks, all of them have giant moisture issues with infiltration coming into the loading dock, eventually finding its way into the cooler, into the freezer, and all the issues that create. On the processing side, meat, dairy, produce, prepared meals, and let's be honest, that's frozen pizza for the most part, right? Bakeries, breweries, pharmaceutical and nutraceutical. So we've had a lot of interest from the gummy bear industry, of course, which is related to our brethren up in Canada and all their newfound product that they're putting into gummies, chocolates, and any other kind of edible. I've also had a lot of conversations about blast freezers. How can we extend time between defrost on those blast freezers? Is there a way to use the low temperature air from a desiccant? Yeah, there is. I mean, we'll get into that a little bit later today, but that's a topic that we wish to explore more in the future. And then cleanup cycles. As this picture shows, a lot of times we're pushed, we're rushed, especially these days, and we'll talk a little bit more about what's going on in the world today. Production is being ramped up, especially in the consumer goods market, and that means we have less time for clean cycles. Dehumidification is a great way to get yourself out of that cleanup cycle faster, get it dried down so you can get back into production. Finally, on the retail side, we're getting a lot of interest from superstores, grocery stores, your traditional convenience stores and traditional supermarkets. All of them are shooting for lower dew points because of issues related to fogging up of the glass on display cases, slip fall hazards in walk-in coolers for produce and dairy, restaurants, groceries, breweries. If you look way up here, the focus of this isn't just on the beer. It's actually the dehumidifier up above it. This was a brewery that, hey, every single one of them has issues with moisture because they're constantly cleaning, they're constantly cooking. But in this case, it was a small craft brewery, and the brewery was also their tap room, so they had to make it comfortable for their patrons. Unfortunately, since that's been installed, they actually, where these kegs are now, it's their kitchen. So that dehumidifier has become also their grease trap. So now they're replacing that filter on. Well, they should be replacing it weekly. Bars, restaurants, okay, all shut down at the moment, but ice arenas, yeah, you guys too. For the most part, everybody in the ice arena world is shut down, or well, let's just say re repurposing your facility for other reasons. So humidity. What what humidity? What's the problem? Take let's take a look at the picture on the left. That is not a freshly washed dock. That is entirely due to infiltration. This was in a very humid climate. I mean, you take a look at those doors. I mean, those are pretty decent doors. The door seals are there, but they had a major slip fall hazard. You also have issues with structural damage, moisture building on trusses, on piping, on sprinkler heads. All that leads to corrosion, which also includes the refrigeration system and its mechanical integrity issues. Most of you who know me know that I spent a good portion of that last 20 years, probably 15 of it, focused on mechanical integrity. And what did I always say? I always said, well, it takes three things to cause corrosion: oxygen, water, and, well, a ferrous material, iron, steel, some forms of stainless steel. Well, you can't get rid of the steel, you can't get rid of the oxygen, so you have to block out the moisture. So we talked about better insulation techniques, better inspection techniques. Well, what about just getting rid of the water altogether? It's a thought that hadn't really occurred to me until I started working for this company. If you drop the dew point down low enough, maybe you can't get the dew point below the surface temperature of that pipe, but you can get the dew point below the surface temperature of the insulation. Let's prevent condensation on the piping, on the insulation, get rid of that. And then, of course, freezer infiltration. What's the real purpose of this loading dock? I mean, yeah, for moving product, for moving pallets, but from the standpoint of those of us in the refrigeration and facility management world, it's our first giant vestibule to stop that moisture from getting into the coolers, getting into the freezers, getting into the ice arena, getting into the walk-in cooler, keeping it out where it's easier to deal with. What about once it's in? Well, all right, of course, decreased refrigeration efficiency. This was actually after defrost on this particular walk-in. You can't tell me that this thing is working at full efficiency if the whole thing is blocked up with this. Product degradation. Again, this was a walk-in for delivery. If you take a look at those boxes, those are pizza boxes underneath there. They can't just pull them out of the shelves and walk out and hand them to a customer. They had to go through a whole defrost process. Breweries, again, this is a big phone call I get all the time. Breweries, they take their cold product, so when it comes out of the bright tank, it's got to be about 30 degrees to get proper carbonation. They put it in cans. They take those cold cans, they put it in the cardboard packaging, and then they don't have enough cooler space. So what do? They roll it into dry storage where it's warm and humid. What happens? The water condenses on the cans, soaks into packaging, and now the packaging starts degrading. And several of these smaller breweries have had to do major recalls because the packaging is full of mold or falling apart, or there's mold growing on the cans, or whatever the moisture related issue is. The point is, they don't need to necessarily air condition that warehouse. They just need to dehumidify it, get rid of that easy moisture. We see the same thing when you get inside the warehouse, inside the freezer. Frost buildup, damage the boxes, makes handling harder, increases that product handling time. Or how many of your times have fork truck driver come to you and complain because their barcode scanner can't scan anything because the boxes are covered in frost? Again, it becomes a major issue. And finally, again, structural damage, employee hazard, regulatory issue. For any of you who are wondering, okay, this is actually down in the Caribbean. This is when I was working on. This is inside the freezer, but this is how fast the moisture was coming in. It was coming in through the loading dock and just whipping right up and across this wall where it would deposit out. These Jamaicans, I don't know if this is where the Jamaican bobsled team practiced or not, but this is where they could make their snow because they made a lot of snow here. You got to put a desking in there or find some other way to stop the moisture from coming in, because the answer, I mean, it's always great to keep the door closed, but we can't keep the door closed 100% of the time. That defeats the purpose of the facility. So what are some of the common myths that we deal with? Evaporator defrost is the only or the best way to remove moisture. It's not the only, obviously. Is it the best? It can be. It can be the best if it's done right, but it's not always possible. For example, the next one, reheat is the only way to control relative humidity. I can't tell you how many jobs I have where, because of the nature of the product being stored, whether it's bottles of wine where the cork needs to be at 50%, or produce or a dry aged beef cooler where you want to keep it at about 70, 75%, or maybe it's some kind of pharmaceutical drug where you need to keep it down 15, 20%, something that seems unreasonably low but has important ramifications on the product. How do you control it to that relative humidity? How do you remove the moisture when you need a relative humidity that low? Well, one option, of course, is to drop your suction temperature way down, because what ultimately controls relative humidity in that, it's the apparatus dew point. It's the coil temperature, the refrigerant temperature. That's going to dictate the lowest RH in your facility if you don't have any other form of dehumidification. So a normal storage freezer, a normal cold storage walk-in distribution center, we're running at, let's say, 0 degrees, minus 10 degrees, like 80% relative humidity. A wine cooler, we're talking 40, 50 degrees, and we want 50% relative humidity, but the relative humidity is going to be dictated on that coil temperature. And if it's just the 10-degree delta T, a 10-degree approach temperature on that coil, you're still talking 70, 80, 90% relative humidity. So the answer then becomes, well, let's drop the temperature. Well, now you're sending very cold liquid refrigerant to that evaporator, even though you're still trying to maintain a much higher space temperature. So what happens when I have a 30-degree delta T between my refrigerant and my space? Well, I fill that coil full of cold liquid, and it sits there. It sits there trying to warm up until it finally can go through the phase change to take in the heat. Well, I've just lost a lot of capacity. And I'm building frost. I'm building frost very quickly because this is a warm, moist air. And in this case, it's relative to the surface temperature, relative to the dew point of that evaporator. When that warm, moist air hits that, it's going to form a hard layer of fluffy frost right on the front of it, and it's going to block up that coil. So now I'm not going to get a lot of movement across it. And on top of that, I probably don't have enough heat in that storage facility to actually do it. So what's the answer? Some form of reheat, right? Throwing electric resistance coils in there, turning on lights, running a burner of some sort, somehow putting heat into that walk-in cooler, walk-in freezer, storage facility in order to get the evaporator to run. I mean, I know we've all done this. Minnesota in the wintertime. If I need to dehumidify and get my evaporators run on the loading dock and it's minus 15 degrees outside, I've got no choice. I got to move heaters onto the loading dock in order to get those evaporators to run to get the moisture out. If that's the only thing I have on hand, right? Another myth, frost is the result of poorly configured refrigeration system. Yeah, blame it on the designer, blame it on the contractor, blame it on the installer. Sometimes it's just the way the facility is operated. This is a beautiful picture of a beautiful facility with beautiful strip curtains. I'm pretty sure this picture was taken approximately 30 seconds after it was finished, because no facility looks like this after fork truck drivers have gotten a hold of it. Strip curtains are broken, doors are broken, things are less than optimal, right? And sometimes it's just the way that it's operated. It's not always the refrigeration system's problem, but we need to look for other options. Frost on arenas ice. For those of you, I know there's several of you here from the ice arena industry. Frost is unavoidable. Well, you know what? So it is if you can't keep your dew point at the same temperature as your ice surface temperature. If you're running an ice surface temperature of 21 degrees, you need your dew point to be 21 degrees. Otherwise, that great big ice surface is just going to act like a dehumidifier. And that's why you come in every morning and find that nice layer of frost over the whole thing that you have to scrape off before either with the Zamboni or whatever means that you're using before the first players come in. Now, is it possible to get too dry and start sublimating the ice away? Of course it is. That's why we need to keep controls on it. And the last myth, dehumidification is too expensive and or too complicated. Is it too expensive? It can be too expensive if it's improperly sized and improperly installed and improperly operated. And that's why we really have wanted to get into this industry, because that was the that was the reality I was living with. That dehumidification with the desiccant was too expensive, because every desiccant that went in was 2, 3, or 4 times oversized. It was too expensive to operate because it sucked all that electricity or gas for reheat. It was too complicated because the industry made it that way, because there wasn't a good understanding of the equipment, the technology, or how to install it. So that's where we'd like to work with you, help you educate the industry on proper sizing, proper installation, and proper operation. All right, so I know what you're thinking. Let me guess. This is the point where I'm going to have to buy something, right? For all those of you over about the age of 45, yeah, you know him, Herb Tarlick from WKRP, coming to sell you something. Okay, hold on. Nope, that comes later. This still comes later. For the moment, let's talk about a few other tips, right? Number one, seal the gaps. So, for fun, just as an offside, after work, fun thing to do, I take care of a curling club here in Madison. And every summer, this is the time of year where we would go in and start sealing all the cat cracks, all the gaps, everything like that. I always get a new group of volunteers every year. And the first question they ask is, well, how do I find the cracks? Hey, that's easy. We show up early in the morning when the sun is low and shooting right on the facility, and the guy with the loudest voice stands on the inside, which is usually me, and everybody else is walking on the outside. And I just keep screaming, keep moving, stop. I just saw a light beam stop. All I'm doing is sitting on the inside of a pitch black facility in the dark looking for any beams of daylight. And once they've covered it up with their finger with their hand, they know where it is, and they can use their great stuff, they can use their caulk, they can use whatever they have to fill that up. That's for the facility, that's for the wall. Do whatever you can to seal the cracks up, because that's where the moisture is coming from. That also includes the doors and your loading docks. Improve and repair them. I know, hard thing, easy thing to say, hard thing to do. Because as we talk, those fork truck drivers, I don't know, they seem to like paint these mental targets on the doors to go after them. So many times I've seen fast acting roll up doors turned into strip curtains because they managed to get the tines through them. Or I've seen big, heavy insulated doors pinned to the wall by fork truck tines. Of course, there's nobody sitting on the fork truck because that guy ran to get his last paycheck and get out of there before he was fired. But we need to make sure that this door technology is in the best shape it possibly can. Now, bear in mind, that is not the ultimate solution, because no matter how good that door technology is, infiltration is going to happen. Moisture is going to get through because at some point the door has to open. And once that moisture is on the inside and it's forming frost someplace, that door cannot pull it back out. So now you either have to be pulling it out with your refrigeration system or with some other supplemental dehumidification. The better door dock management. Again, easier said than done, right? Too many times I've been in facilities where repair of the doors, repair of the seals, repair of the truck doors, it falls on the budget of operations and maintenance. Okay, that makes sense because it is a maintenance item, but some of the most successful facilities I've seen, they push that and they put that bill, they put that expense on logistics guys on their budget. So now, whenever a fork truck driver would go and destroy a door and it had to be fixed, it came out of logistics budget and they had to account for it. And they were held more accountable. They were held accountable financially by the finance department, and not just, hey, shame, 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 you shouldn't do that. Talk to, those of you who are contractors, talk to your clients about thinking, what's a better way to motivate better door and dock management? Look at your coil temps. Look at your apparatus dew point. We're going down to this last line. Get the easy water first. Do I need to run my dock at 25 degrees, at 35 degrees, at 40 degrees? Can I maybe raise it to 42 degrees? Why 42 degrees? Because then with a 9-degree approach, I can keep my coil running at 33 degrees, 34 degrees, 35 degrees. What does that get me? It keeps it wet. It keeps that loading dock coil running where it's going to do the most moisture removal to get rid of the easy water first. Now, I know some of you have USDA requirements to stay at 40 degrees or below. If so, understandable. But do your best, because anytime you start dropping that coil down below freezing, it takes more energy to take the water out of the air in the form of frost. And then you lose time and you add heat when you go into defrost and you try to get that moisture out of there. So do what you can to run it at as high of a temperature as possible to keep the water flowing. Reduce that infiltration moisture right from the start, right? So if you are a kitchen, a restaurant, some sort of facility with a walk-in cooler, walk-in freezer, humidify the kitchen. Catch that moisture where it is first. If you're an ice arena, the locker rooms, the hallway, the clubhouse, wherever it is that the moisture is coming from, dehumidify that first. The loading dock, again, stop it from coming in. And as I mentioned, we're working a lot with grocery stores, super centers, things like that, to get a 45 to 50 degree dew point. That kind of seems to be the magical point where we can still reach it with refrigeration, mechanical dehumidification, and do so very efficiently. But at that level, that significantly reduces the amount of moisture that's going to get into the walk-in, get into the freezer, deposit on the doors in the form of condensation, right? Deposit on the windows of the ice arena. So your clientele can't look in and see their cute little child doing pirouettes or playing hockey. We want to get that easy water first. And one last one, seal off that loading dock from production. Yeah, who is king? Yeah, we all know, right? Production is king. Production is always king. And logistics comes a close second. They want to get that product from production to the loading dock as fast as they can so they can get it in the freezer, which often means that is wide open. Okay, when they're actually in production and they're running that space at 50 degrees, that's fine. But what happens when they go into cleaning cycle, from 11 till 8 a.m. or 6 a.m. or whatever your cleaning cycle is? Well, now all the water that's in production is finding its way over to loading dock and it's finding your way into the freezer. Do your best to get a door in there and at least be able to use that door during the worst times. Keep it out. So I tried all that. Now what? Well, again, okay, warning, here comes the sales pitch. It doesn't need to be difficult. Quest can help. Yeah, just so y'all know, so I introduced myself as applications engineer. I started out as sales engineer, but I kind of suck at sales, so they changed my title. But they still let me do these webinars. So, hey, we can help at any dew point. Seriously, we can help you at any dew point. We're one of the few manufacturers, if not the only manufacturer in the world, that offers both mechanical refrigeration and desiccant technology. So for your warmer spaces down to about a 40-degree dew point, we have the most efficient dehumidifiers in the world. What we have is this patented 3-coil evaporator system. Don't have time to talk about it now, but we will be doing webinars in the future. It's something we could talk about down the road. Easy to install, capacity is up to 876 pints per day. Once you get below that 40-degree dew point, down to minus 40, or maybe even less, not too much lower though, we have our Trotec desiccant series. These units are made in Germany, but they're finished here in the US because we have to finish them to the 60 hertz market, get the whole UL certification, and do a few other modifications to make them suitable for our market. But we've been bringing them over for a bit here, and we couldn't be happier. The installation on these is relatively simple. It has infinite variable airflow capacity. I'll talk about that. And capacity is up to about 4,000 pints per day or 175 pounds per hour. So for those of you who are new and are saying, hey, what's a desiccant? Just a quick overview. Desiccant is basically, desiccant material is when you buy a pair of shoes, you buy some electronics, you find that little package that says do not eat. Why should you not eat it? Because it says do not eat on the package. Apparently somebody did at one point. So what happens is we take that desiccant material, silica gel for the most part, and we spray it on a honeycomb wheel. So here's a cross section that you can see. And through that honeycomb wheel, we're going to draw air from your facility, whether it's drawing it from the walk-in cooler, from the distribution center, from the ice arena. It's going to pull that air and pass it through that honeycomb wheel. And as it passes through, some of the water will adsorb, not absorb, but with a D, adsorb into the desiccant material and fill it up. So now the air that's coming out is going to be much drier. It's also going to be a little bit warmer. It picks up a little bit of heat in the adsorption process, sort of like latent heat of vaporization, removing water from air under mechanical refrigeration. Here, we're we're adsorbing it, but there's energy involved. Nothing comes for free. So therefore, the air picks up a little bit of heat. So now, eventually, this warm, dry air can now return back to your space and dehumidify your space. But the wheel eventually is going to be full. So what we're doing is slowly rotating this wheel, about anywhere from 10 to 12 rotations per hour. But again, we can vary that number based on your parameters and your needs. Speeding it up, slowing it down can change both the capacity and the moisture removal, but we'll tailor that to what you need. So now it rotates through to our regeneration section. So in the regeneration section, we're going to add heat. We're going to take a second stream of air. This air could be coming from outside. Could be coming from your dry storage warehouse. For ice arenas, it could be coming from your clubhouse. We want the warmest, driest air possible to start out, and we're going to add heat and heat that up to somewhere north of 200 degrees Fahrenheit. Probably 220, 230, 240, depending upon how dry we need the wheel to get and how cold that air is to begin with. And now that warm, dry air can pass through the wheel, push the moisture back out, and now we have this warm, humid airstream that we want to throw outside. Get rid of it, chuck it back out where it belongs. Up through the roof, out through the wall, wherever we can get rid of it, we get rid of it. There's no condensate line. There's no line of water coming out of this particular technology. It's just that warm, humid air, and we need to get that out of the facility. If I go back one, and you take a look at this desiccant, this is one of the smallest in line. This is my process inlet. So this is taking air from the facility, and I can always tell an inlet, the return air, because there's a filter there. The process out, or the supply air, is going to be coming out the other side. And in this particular model variance, we have actually regeneration air in and regeneration air out. It does kind of a U-turn there to provide a chance to preheat the air and kind of cool the wheel, because when it gets done with regeneration, it's pretty warm, right? And we don't want that hot wheel first impacting the air. So in this process, we actually pre-cool the wheel and preheat the regeneration air before it goes through the wheel. Gives you a little efficiency boost and a definite capacity boost. So what's the desiccant going to do for you? Well, all those problems we talked about, we're going to stop the conditions that create mold, mildew, staining, and bacterial growth. Right? We're going to drop that RH to something low enough to stop those processes from happening. Reduction of defrost cycles. Yeah, we're pulling moisture out of the air that your coil doesn't have to. This could be by simply acting upon the space itself, or in a lot of cases, what we've been working with customers to do is introduce that dry, desiccated air, a little warm, right into the back of the evaporator, whether we're talking a blast freezer, a walk-in cooler, or a large freezer. Putting that air in there, and this serves 2 points. So 2 purposes. First, that dry air goes in and it will sublimate some of the frost off of the coil itself. So it gives you a little bit more time between defrost. And now that warm air hits the evaporator first, we don't have to worry about the warm air dropping on product. So it catches the moisture there. And then also, hey, it kind of acts like a form of reheat, right? It's going to keep that evaporator running a little bit longer to get a little bit more moisture, so it helps in that process. And corrosion. It curtails condensation causing corrosion. There's your alliteration for today. Catching the moisture in the air so it isn't dropping out on our structure, on our piping. Or for those of you in the ice arena world, it isn't condensing on our ceiling and dripping down on the ice and creating those horrible, horrible stalagmites, icicles, whatever you want to call them, moguls, if it gets bad enough that you have to spend all morning scraping off. Reduced energy consumption refrigeration system. I know. Wait a minute. This is where it's getting thick. Put down the rubber boots, right? Dan's talking about saving energy. with a desiccant. No, seriously, it can be done. If it's properly sized, properly operated, you can save energy. How? Let's think about the ice arena. If I am doing my dehumidification with the ice surface, forget the effects upon playability. But what am I doing? I'm removing that moisture with a refrigeration system that's running at what? 2 horsepower per ton, 2.3 horsepower per ton. It's not cheap to pull my moisture out of the air with that method. Suddenly, using a desiccant can actually save you energy. On again, my own personal ice arena that I take care of, I saw with an electric desiccant, I saw a 30% reduction in gas consumption because my furnace wasn't running as much. But I also saw a 7 to 8% reduction in electric consumption because the desiccant was taking care of the moisture instead of the compressors. Same thing, think about your walk-in cooler, your walk-in freezer. If you are doing less defrost cycles, that's less heat you're putting back in from the defrost process. If it's a blast freezer, dropping that warm, dry air in there, if you can extend the production time, maybe there's energy savings, but there's definitely a production increase, right? We go through a lot of different methods to try to increase runtime between defrost and cleaning cycles. I'd love to work with you to make this another one of those tricks in your bag of tricks there. Eliminate slip fall hazards. I mean, that one's obvious. If the moisture is being taken by the desiccant, it's not condensing on the walls, it's not condensing on the floor, it's not forming ice for people to slip on. Regulatory compliance. I can always tell when OSHA has been someplace and someone is in big trouble because they don't start out by saying, I need a desiccant. They don't start out by saying, here's my issue. They start out by saying, what do you have in stock right now? I need something shipped immediately. And a lot of times we have stuff in stock. That's one of our value points is we are planning on keeping these units in stock, at least a few models of each ready to ship out when you need it. So a lot of times that regulatory compliance is USDA, it's OSHA, it's EPA, it's somebody talking about slip fall hazards, corrosion issues, ice buildup, right? And again, these are all major issues affecting our industry. And finally, accelerating the cleanup of drying. Talked about that. We're getting less and less time for our cleaning cycles. It still takes the same 2 to 3 hours to clean everything. Now we need to look at on that spring day when it's 60 degrees and 100% relative humidity because it's raining out, how do I get my production dry? I can't bring in any more outside air. I'm already running as fast as I can, and that outside air I'm bringing in doesn't have enough capacity to take that out. Close the whole thing up, put in a couple of dehumidifiers, that'll pull the moisture down, right? Just taking a look, this is our product range. These are 480 volt units. We have a couple that are 220 volt that are about 80 to 110 pints per day. This one starts at 190 on up to about 4,000 pints per day. If you're looking at CFM, that would be about 80 up to 4, oh, I'm sorry, zero up to about 8,000 CFM. Because, why do I say zero? Because we're 100% variable airflow on both process airflow and regeneration airflow. It can be set by simple potentiometers inside of the unit, or on some of them, they have what we call the Flowmatic system, where it will, on the fly, adjust the CFM to account for changes in pressure drop. So if the filter's loading up, if a damper goes half closed somewhere downstream, the unit will see that change in pressure drop and it will adjust accordingly to maintain a constant airflow. It also has multiple heating banks that are controlled by solid state relays, again, to give you nearly infinite control over the heat that's being applied to wheel to hold the humidity where you need it to be. So you can control that airflow, you can control grain depression, you can control unit capacity. It's all there for you. For those of you who are contractors that need to work on these, the parts are easily sourced. So everything is that we try to get it so everything that you need to make repair, except for the desiccant wheel itself, can be sourced from your local HVAC supplier. We're talking to EBM PAPS fans, Eaton Electronics. I mean, these are all brand names that are easily recognizable. The desk and wheels themselves, we'll keep those on site. Field upgrades. These particular units, there's a couple amazing features here. So this unit, within this platform, there's actually two sizes. On these three platforms, there's actually three sizes. How do I get from one size to the other? It's simply a matter of adding a larger desk and wheel, adding more fans, and adding more heater banks. So if you're not sure of the load, and hey, frankly, no one ever is, right? Calculating moisture infiltration load is hard. It's not as easy as calculating the sensible load. So there's always that question. And that's the problem that our industry has had with desiccants. We weren't sure what the size was, so what did we do? We figured out a number and we added on a safety factor of 50%. And then it went to the next guy who added on a safety factor of another 50%. We then went to another guy who probably added on a safety factor of 100%. We're now 4 times oversized. All right, let's back up that train, figure out what we need. And what I encourage people to do is if they don't know how accurate they are on the size, pick the smallest unit in that platform, right? So for example, this one is our TR 570, so 570 pints per day up to 1100 pints per day. Pick the small size, and then if you need to field upgrade, it's a simple matter of putting in the new deskant wheel, adding more heaters, adding more fans, and those you can pick up from your supply warehouse. You only need to talk to us about the deskant wheel. Controls, most of these have onboard PLCs or the option for onboard PLCs. Therefore, they can be controlled with 0 to 10 volt, 4 to 20 milliamp. It has its own proprietary controls. We're also working with all the major controls manufacturers, like Emerson's E2 controller, BACnet compatible, whatever your favorite is, let us know what it is, and we'll make sure that we work with them. And the final thing is this unit's reversible. You don't want process inlet on the left side and outlet on the other side? It's okay. Open these doors, pull everything out, and flip it around and put it back in. You can flip this 180 degrees so the process is going the other way. And this isn't even at the time of manufacture. This is if you need to repurpose it for a different process. Completely reconfigurable, and the unit will know what it's doing and be ready to go. So why Quest? Why are we asking for your business? Well, we do create the most energy efficient dehumidifiers in the world. We've got 28 patents on refrigeration technology to get us to the high levels of efficiency, and we want to carry that same mentality over to the deskant market. We want to become the producer of the most efficient deskant dehumidifiers, and well, that's a difficult thing to say. Most of it comes from proper application. So we were willing to work with you to make sure that you're getting the right size for the right application. And as I said, we're stocking the product. Now, I can't promise you every size at every time because orders are coming in as fast as we can send them back out, but we're going to do our best to make sure we keep things in stock. One last slide. This is something that we added kind of last minute. As I was looking through, as all of us are doing right now, you're kind of reading the news, checking on the COVID topics. And I saw this graph about sales to the consumer market through grocery stores, through supermarkets. And likewise, if you look at a similar graph for, restaurants and large food service and school lunches, you're going to see an opposite trend. What's going on? It's kind of the same thing that we saw during the Great Recession of 2008 to 2010. I don't remember how many of you were in the industry at that time, but I was. And I can tell you my whole philosophy on life and every job that I was doing at took a radical shift as people stopped going to the restaurants, stopped going out to eat, and came back home to start cooking at home. Well, you know what they discovered? They didn't know how to cook. So they turned to frozen pizza, ready-to-eat meals, frozen dinners. What we're seeing now is the same thing on steroids, and honestly, we don't know how long this is going to happen. So a lot of facilities are already going through a rapid change in what they're producing, how they're producing, and what markets they're shooting it for. You look at dairy, and it's showing a stark increase. And yet here in Wisconsin, the news is that they're dumping thousands and thousands of gallons of milk every day because the schools aren't open to accept those cartons, because everybody is switching. They're buying the gallon totes, and so production is very rapidly moving over to jugs and bags of one gallon or 1 liter milk. Some of these numbers, 46% increase in skim milk through grocery stores, shredded cheese, frozen pizza. That's not surprising. Frozen cookie dough, those are the biggest number, 570% increase. I believe that based on watching my daughters in the kitchen and how many cookies that they're making. As things are rapidly changing, and we're working with pharmaceutical customers, food production customers right now that are pulling equipment out of mothballs, getting it up and running, and of course, there's frost-related issues. So those are things we need to address. We are planning on doing more webinars in the future. We have plans for doing another one in about 2 weeks, and you'll all get an invite. So we're looking, what's your interest? What other topics are you interested in? And in the future, this doesn't necessarily have to be Dan talks and you listen. We'll have more interaction, maybe bring some of you on board, talk as well. So one topic is what we just covered, dealing with frost and rapid changeover and build-outs. Or a question that I get often is, how do I determine the moisture load for my distribution center, for my walk-in, for my ice arena? How do I know how to size my units? Another one, is it possible to save energy and or my budget with the desiccant? We talked about it. It is possible in some situations, in many situations. How can I take advantage of that variable CFM desiccant? What does that mean for me? It means I could either increase capacity or I can increase green reduction, get drier air. Lots of possibilities there. How can I enhance my desiccant's performance? And I'm more than happy to, if it's not our unit, that's fine. Give me a call. I'm more than happy to talk about anybody's unit. When do I switch from mechanical to desiccant dehumidification? What's the best application? Where's that cutoff point? Again, it's a very confusing, it's not a hard fast at 41.2 degrees Fahrenheit is where we switch over. It depends upon the situation. It depends upon the application and the ranges that you typically see. But there is definite guidelines. Another one that comes up quite often, how should I install a desiccant in my ice arena, in my walk-in freezer, in my walk-in cooler, in my gummy bear drying out kitchen, in my distribution center, in my blast freezer, whatever it is? How do I get it in there for the best grain depression, or for the best capacity, or to capture the most moisture, or to reduce my issues? Let us know. We'll be looking for you. Feel free to email us. There's my email address and Walt's email address. He's our desiccant product manager. Throw it in the comments right now. Any way you'd like to communicate with us, let us know what you'd like to hear about in the future. With that, I will hold off and see if anyone has any questions. Feel free to type them into our live chat Q&A.
Thank you, everybody, for joining us. We have a question that came in, is how do I install the units, practical space requirements, Revit models available?
Okay, all right. Well, we might have to go back over those, but okay, how do I want to install this unit? Let me go to this slide. Think of it this way, and again, it depends on the application, but usually the air I'm bringing in, I want it to be the most humid possible, right? This desiccant, it reacts more to humidity than it does to temperature. So for example, on a walk-in cooler, what I always tell people to do is pull the moisture from the door, right from in front of the door. And now I know others will say, hey, let's drop the warm, dry air down in front of the door and let it act as an air curtain to catch the moisture that's coming in. Yeah, I get the idea, but the problem is we can't get enough velocity going to get a true air curtain to happen. Plus, usually my desiccant isn't going to be running until after the door opens, so it kind of defeats the purpose. So instead, let's put that desiccant so it's pulling as soon as the door opens and that warm, moist air comes rushing up and in. Put the desiccant where it can grab that moisture, run it through the desiccant, pull it out, and then again, drop that warm, dry air back in behind the evaporator to take it out. In the case of an ice arena, I wanted to pull the air from a pie. Humidity tends to rise, so I'll pull that air from a pie that has the most moisture and try to distribute it throughout. Now, what I want to make sure I don't do is distribute that warm, dry air right across the ice. One of the very first applications of a desiccant in a curling club, I won't say the name, but silly Minnesotans. As a Packer fan, I have to throw that out. They distributed the air right out across over the ice, and it created a ditch because it sublimated a nice little ditch. So the stones would be rolling down the ice, and you'd hear them go ba-bunk as they continued on. Ducting. Now, as far as physical placement, I should also mention, where do I want to put this unit? If possible, put it outside of the cold space, right? Why? Because when that regeneration air comes out of there, it's going to be very warm and very humid. And I don't want, even if it's insulated, I don't want it running through the cold environment, because what's going to happen is that duct work is going to get colder. The air is going to cool off to the point where the water drops out, and now I got liquid water to deal with instead of humid air. So if at all possible, get this unit out of the cold space and duct the cold process air to it and back again. Do we have another question?
There are no new questions that have come in, but we'll keep the chat feature open for a few more moments. And if you can put your contact slide back up, you may also get a hold of Dan and Walt through the email addresses that are on the screen. And we'll just keep this open just for a few more moments. Feel free to use the chat feature.
And by all means, let us know. I mean, if you're interested in hearing additional, let us know what you'd like to hear.
Okay. We don't have any more questions that come in. Thank you, everybody, for joining us. We hope you found this webinar informational.